Hi, this is Abdurrahman Ayman. In this video, I will be teaching you how to use the Point3d Struct on RhinoCommon. So if you go to the RhinoCommon API, under the Geometry, the Geometry tab, you can find all the geometries used as described before, and you can just scroll till you reach the Point3d Struct. And here you can find that the Point3d is a struct. We can say in coding that it could be handled like the classes, and here we can find that it's under the the Geometry namespace. The Point3d struct has some constructors, 5 constructors actually, 8 properties, and 25 methods. In order to construct a point and as a struct, all you need to do on C# is to write the struct's name, which is Point3d, give it an identifier, let's say point A, and that will be equal to again the struct name, which is Point3d, and before that we have to type new Point3d to initiate a new object of the class, and here we can find the overload. So if you go with your upper and down arrows on your keyboard, you can choose which overload you want to use. So a simple way to construct a Point3d is by using the x, y, and z coordinates, which are typed as doubles. So we can just type 2 as an x location, 5 as a y location, and 0 as a z location. And then we'll have to assign that value or that object to the A output. So we say A equals to point A. And now if we run our program, it's working now, and we can find our point here exactly at the same location, which is 2 on the x-axis, 5 on the y-axis, and 0 on the z-axis. In order to get those coordinates from the inputs of the script, we can just type here x, y, and z. And of course, if we run the script, it will give us an error because the z is not added to the inputs, and still we have some errors here because the x, y, z are assigned as objects, not as doubles, and the Point3d needs doubles in order to be constructed. So all we have to do is right click on x, go to the type hint, and choose double. We'll do exactly the same with the y and the z. And now the script works well, and it will give us a point at the 0, 0, 0, which is the default values of the x, y, and z. So if we need to change those values, we can type number sliders to change the values of x, y, and z. And we can say now that we have a point script here that does exactly the same as the construct point component on grasshopper with the x, y, and z. Of course, we can change the x, we can change the y, we can make exactly the same component, and we can name our output as pt, and in this case we'll say here that pt equals point A, and Point3d we have to write now the x, y, z in the uppercase letters, and here we go. So we have here our C# script that does exactly the same as the construct point. We can name it construct point, and if we click on this bucket, we can get the name of our component here. So what else can we do with the points? Actually, we can set our x, y, and z, so we can create a new point3d and then say point a dot x equals x, and point b and point a dot y equals y, and point a dot z equals z. And in this case it will still work, and it will take the xyz values from the sliders right here. And here this property of the x, y, and z is actually a property we call it getters or setters. So you can get the value of the x, y, and z, or you can set them. And in this case here we are setting the values. So if we say that we still work it this way, so we have a point with the x, y, z, and we want to get the x or the y or the z coordinate, we can just add an output here and call it x location, and let's make here an underscore. And in this case we can say that in x underscore location equals point a dot x. And if we run the component and add a panel here, we'll have the same x that we added by the number slider, and if we change it, we'll find it changing also in this panel. So if we go back here, we'll find that there are some properties. Those are really useful. One of them is the unset, because somewhere in the RhinoCommon API, in some geometry, some overloads have to take a point3d that you don't want to add. So all you have to do is point3d.unset, and then you are unsetting the point, or you are not giving it a location. Okay, and here we can get the maximum coordinate or minimum coordinate, and here are the getters or setters. So it says gets or sets the x coordinate of this point, and the origin here. So if we need to find the origin, which is 0, 0, 0, all we have to do is add another point. Let's call it origin as an output and say point3d dot origin. And if we add here an output and call it origin and run the script, it will add a point in the 0, 0, 0, and if we plug it to the slider, we'll have to the panel, we'll have this 0, 0, 0 coordinates. There are some methods, so we can sum 2 points together, add them together, and get the another point. So if we create another point, let's call it point3d point b, and say equals new point3d, but this time it will be 1, 1, 1. What is the value of adding those 2 points, 5, 4, 0 and 1, 1, 1? It will be the x coordinates of the new point will be the sum of the x coordinate of the first point and the sum and the first coordinate of the second point. So we can create a new point3d, we call it sum, and here we say point3d dot add point3d1, which is point A, and point B, and this will give us a third point. So if we here call a new output, let's call it sum, and it will equal to sum. We'll just add another output here, call it sum, and run the script, and here we'll have another point. So if we plug here a point component to check, this is the result of adding our point A, which is 540, to the 111. Okay, it's another point that equals to 651, and this is logical, right? The same exactly, we can divide a point by a parameter or by number, So it means actually in mathematics that we're dividing each location or coordinate of the point by this number, and we can multiply a point by a number, and with the same logic, the x coordinate will be multiplied by this number, the y coordinate will be multiplied by this number, and the z, etc. We can subtract 2 points. We can get the distance between a point and another, and in this case we need to check something. Here, when we use the add method, this is actually a static method. So to call a static method, you have to call the struct name. While if this method is not static, you have to call it by your object, by one of your objects that you want to get the distance to. So if we want to get the distance between point A and point B, in this case we'll say, and of course a distance is a double, so we'll say double distance equals point A dot distance to point B, and we'll add here the distance output, which is equal to distance, and we'll add here also the output, and here if we run the script, it will give us the distance between the 2 points exactly. Also, we can interpolate between some points. We can transform the point, meaning we can move a point, we can rotate it, we can scale. Of course a point is not scalable, but here in this case the transform method is under the Point3d class, and to call a transform method, all you have to do is say point A dot transform and open the brackets and type transform again, and dot, we choose translation, and translation takes a vector or 3 doubles, which is the distance in the x, y, and z. So if you want to move it in the z direction with like 3 meters, all we have to do is write 0, 0, 3, and that's it. Okay, and here we have to close the brackets actually, that's why the error appeared, and now it works. Okay, so we'll find that point A is moved by 1 unit in the z direction, and if we find the sum, in this case the sum is not affected by this transformation because the sum is called before the transformation. So if we call the transformation first, let's cut this here and type it before the sum. In this case the sum will be 4 in the z, so 0 plus 1, which is here, plus 3, the translation. So the sum here happens on the new place or the new location of the point after transforming it, after moving it to the z. In order to create a point, you can create it using methods, and this will help you write less code than writing this long line. So how can we do it? All we have to do is to create a method here in the custom additional code, and in this method let's give it a name. So first its type is Point3d, and we need to give it a name, so we can call it create point, and here we have to give it our arguments, which are x, y, and z, right? So we'll type here x double x, or we don't need actually to write double x, double y, and double z, because the x, y, z are learned as doubles from this, right? No, I'm sorry. Okay, we'll have to write here double x, double y, and double z. And what does this method do? So this method will create a new point. So it will create a new point, point3d, point a equals new point3d, which is used by which is got by the x, y, z coordinates, and we'll return point a. So what will happen here? All we need to do now is say a equals CRT point and give it the x, y, z that we need, which are 5, 4, and 8, for example. And if we run this script, hopefully it works. No, the name a does not, yeah, we didn't add here an a. So if we add an a here, yep, it gives us the point. So we could create a point with a really tiny line of code with much less characters, right? So this really helps if you want to create a lot of points. So instead of typing point3d, give it a name, and equals new point3d, all you have to do is write your class, your method name, and just give it some parameters. So if we run this and add the b, we'll have another point here. That's it for the point3d class or struct in the RhinoCommon, and see you in another video. Thank you for watching.